Well, hello. We are live right now. My name's Chris Jones. I'm with the University of Arizona Cooperative Extension in Gila County, and we are here for the Septic Smart Week 2022 webinar series. So thank you everybody for joining us today to learn about septic tanks and all things septic and on-site wastewater related things. And today we've got Alex Kendrick with us. So good afternoon, Alex. How are you?
Good afternoon. I'm doing well.
Great. Well, folks, let me give Alex's little biography here. Alex Kendrick graduated from California State University, Chico in 2012. He majored in mechanical engineering. Out of school, he headed out to work in the Bacon oil fields in North Dakota. And after spending a few years with Halliburton as a field engineer, he moved over to Rugby Manufacturing and designed custom work and dump truck beds. He eventually moved home to Arizona and started working as a regulator for Gila County. He currently observes perk testing, subsurface soil analysis, reviews on-site wastewater system designs, and does inspection for the installation of on-site wastewater systems in Gila County. So welcome, Alex.
Thank you.
You had a little bit of an adventure there, some of those careers.
Yep.
Nice. Was it cold in North Dakota?
It was, yes.
I can imagine.
I moved back to Arizona.
Great. Well, this is something where I'm glad to have everybody here, whether you're a homeowner or somebody in the industry, just a great opportunity to learn about the septic systems. And so today, particularly, we're getting into what is a septic system. And so, Alex, why don't you just go ahead and pull up your slides for us here. We'll hand it over to you. Everybody who's here, feel free to make your comments in the chat or the Q&A. And if Alex feels like he wants to answer any of those while he's in the middle of the presentation, feel free to do so. Or typically, he'll give the presentation and then we'll handle the Q&A and chat afterwards. So Alex, the stage is yours. Thank you for being with us.
Thank you, Chris. All right. So like Chris said, welcome to Septic Smart Week. This is our second day. And so I'm just going to basically cover the generalities of what is a septic system. Too far. As Chris mentioned, Alex Kendrick. I work for Gila County as a regulator. I've been in the wastewater industry since 2020. I came from the Bakken oil fields of North Dakota. As a regulator for Gila County, like Chris said, I do on-site system design reviews. I inspect system installations, and then I observe the perk and subsurface soil testing when it's done in Gila County. So since we're talking about the on-site system, it's important to understand what's the reason for an on-site system. To look at this, we need to address what is the residential water cycle. So I got two pictures pulled up here, and I'll try not to point to my screen because I recognize you guys won't be able to see what I'm pointing at. But basically, these are both the residential water cycle diagrams. So as you can see, water comes in from either a well or a water company, or you haul it in, you use the water in your home, and then at that point, most people don't think about what happens after that. Well, what happens is it goes into your septic tank, and then eventually it goes through your septic tank and into some sort of disposal work, whether that's a trench, a pad, drip tubing, some sort of advanced treatment. And then it leaves that disposal works and goes through the ground until it reaches the water table again, where it's then either pumped back into the house from a well or treated at a water company again. Some things to look at. If we're looking at the image on the left, Notice that plumbing vent up there. Many times people think, well, I don't want risers, or if I have my septic system or septic tank right next to my house, I'm going to smell it all the time. If you're smelling your septic system, it means there's a problem going on in your septic system, because that plumbing vent is supposed to make sure all of those odors don't actually stick around your house. If you look over on the image on the right, you'll see that there's risers, there's a septic tank, there's an inlet and an outlet, there's a transport line, there's what we call a distribution box or a D box, and then there's some sort of disposal works with an inspection port somewhere at the end of that disposal works. A lot of older systems, you won't actually find those inspection ports, but it's very important if you have an on-site system to know where your field is. You don't want to be building over it or building too close to it. So that's basically the residential water cycle. I'm going to move on and just talk about each of these components, and then we'll get into some scenarios. This is a septic tank. This is a basic side view of a septic tank. You'll see on the left, there's a inlet. In this case, it's into a sanitary T. Sometimes there's, on the older tanks, there's a cement baffle right there. But basically your sewage is coming in and it's landing in this first compartment. Right there, about 2/3, you'll see that there's another wall with a hole in it. That's your baffle. And that's keeping what's happening in the first compartment from happening in the second compartment. So in the first compartment, you'll see that there's a couple of different things you see. The first being the layer of scum on top. Fats, oils, greases, just like any other fluids, don't necessarily merge with water. They separate. And so the stuff that is lighter than water, such as oils, tend to rise to the surface. The stuff that's heavier than water, right, and the solids, they sink to the bottom, and that becomes your sludge layer. That layer in between that's unmarked is your clear zone. Now, that's not actually clear water. It's just not sludge or scum. It still has particles and effluent in that. So don't get that misconfused. The purpose of this first compartment is to allow time for the scum to rise and the sludge to settle, so that when that clear zone moves into that second compartment, you don't have all these contaminants that eventually move out into your disposal field. The second compartment should have another sanitary T or another baffle like you see on the way out. And it should have some sort of filtration system in that sanitary T. That filter is to keep the smaller but not microscopic particles from getting out into your leach field. A lot of times you'll see in advertising for additives, it'll help keep you from having to pump your tank. All that's doing is breaking down that scum and sludge and running it out to your leach field. So be careful about making sure that you're addressing both your tank and your disposal works when addressing your septic system, because taking care of one and neglecting the other can lead to a failure just as easily. So after it leaves the tank, it goes to the disposal works. This is a standard leach trench diagram. So for a standard system, this is a fairly good illustration of what's going on. You'll see there's a couple of different layers. You have good soil on top of a filter cloth, which is on top of a leach pipe, which is on top of leach rock. And then there's another layer of good soil before you get down to all these interesting little images below, like a water table. I mentioned in the water cycle, everything eventually goes back to the water table, or it hits a rock shelf, or it hits some fractured rock. The reason those are important is those restrict downward flow. So you want to make sure that your system is functioning properly and that the effluent is clean by the time it gets to the water table, and that it's got enough soil between the leach rock and whatever limiting factors are under that ground that you don't end up backing your system up. An important thing to understand is we discuss this leach trench diagram. So your effluent's coming in and it's building up what we call a biomat. And that's basically the food for all of the microbes and little bugs that live in the soil to eat. And so as this biomat is building up from the inside, you have aerobic bacteria and bugs on the outside eating it. And eventually this biomat builds up across the entire leach line and then reaches a state of equilibrium where what's coming in is being eaten by the bugs. This is a good thing. If your system becomes super saturated, or if the amount of bugs gets killed for some reason, mainly through anything that's harmful to microbes, then it affects your system and then it's not functioning properly. As I said on that previous slide, if you're putting too much of your effluent particles into your leach field, then you don't have that balance in your biomat. And so your field actually ends up dying. Not every system in the state of Arizona can be a standard system. Right now, Arizona code allows for alternative systems that make sure that any parcel that requires an on-site system in the state of Arizona can have some sort of on-site system, depending on limiting factors such as cost and needing to keep the water level or the effluent, or clean the effluent to the point that it can then be returned to the water table without polluting that water table. Certain alternative septic systems that are readily available are pads-based systems. Basically, they're like a fancy leach field. The idea is that they bring in more surface area for those bugs and microbes to live on so that they can eat through the effluent quicker. Aerobic systems are designed so that added oxygen is entered into the equation. Just like any living creature, if we don't have air to breathe, we die. Microbes are the same way. So adding oxygen to the system allows the microbes to have more air so that they can propagate and eat through the effluent quicker. Filters, sand filters, media filters, textile filters, there's all sorts of filters. The general idea is that just like pads, they add more area, surface area for the microbes to live on. And there's generally recirculation going on so that the effluent is actually treated multiple times in that filter before it's then discharged into the ground and then eventually into the water table. And tune in Friday for future experimental systems with Joelle. She'll be talking about the state of Arizona and the idea of trying to come up with new systems that treat the effluent and maybe deal with a little water reuse as well. When you don't have a good system, up until the 1970s, cesspools were actively used throughout the state of Arizona. The difference between a septic system and a cesspool is, as you see in this diagram, a cesspool is basically just some sort of structure, whether it be cinder blocks or 55-gallon drum or a VW bus that's just buried and the bottom's cut out of it. And the line comes in and everything gets thrown in there, and then it's trusting that the liquids and effluents end up leaving through the bottom, and then that you end up pumping the rest of that system when the solids build up to the point where you can no longer use it. The problem with this is there is no treatment going on. So whatever leaves out that bottom leaches right into the water tables, leaches right on out to your neighbor's property, all sorts of problems. And so that's why the use of cesspools has been prohibited in the state of Arizona for greater than 50 years, but you'll still come across them. So if you don't know whether or not you have a septic system or a cesspool, I recommend contacting a wastewater provider and finding that out. Upgrading your cesspools to a effective wastewater system, whether that be alternative or standard, all depending, would greatly increase your property value and help you clean up the environment at the same time. So the reason we have setbacks is in Arizona code is to address the fact that we need to keep our environment clean. Arizona code has two types of setbacks. It has vertical setbacks and it has horizontal setbacks. The vertical setbacks, if you think about cutting the earth in half and looking at the different layers, that's going to be your vertical setbacks. So you need to have a certain amount of space of good soil between where the bottom of your leach field is and the top of either the water table or some sort of limited condition like a rock shelf, because the bugs need to have enough time to get the water clean before, or get the effluent clean before it reaches that water table, or before it backs itself up if there's a limited condition such as a rock shelf, and then it starts to surface. But that's a whole other problem if you're coming across that. Horizontal setbacks are important, or just as important. You don't want to put your home right over your leach field. That not only affects the ability of your leach field to function, but it also affects the stability of your home. And naturally, you also don't want your leach field leaching right into your well. If you flush the toilet and your well water rises every single time, you probably want to get that checked out. So why should we keep our systems in good repair? Why should we care about those regulations I just talked about? And what are you drinking? So why should we care for our systems? If we fail to care for our systems, not only are we polluting the environment and making our property values drop, but we're also hurting ourselves. The two images you see on the screen here are two fairly common critters that most people know of, Salmonella and E. coli. If we're not properly treating our water and giving the soil time to clean, the bugs time in the soil time to clean up the effluent, then all we're doing is drinking all the bad stuff that's coming out of our system. Likewise, for regulation, the reason these regulations are put into place are not to, right? They're not the man putting the thumb down on the on-site wastewater owners. It's to help make sure that when we have this effluent leaving our system, by the time it gets back into our home through the residential water cycle, it's clean and it's safe for drinking. For those of us listening in who are thinking about possibly a career change or wondering what this could mean for you, there's a ton of available jobs going on in the on-site world right now in Arizona and across the nation. If you just want to dip your feet in lightly, soil evaluators, perk testers are needed throughout. U of A has a great program. You look at some of their classes, they'll get you can get signed up for those and you can get qualified to perform soil evaluations and perk tests. On-site system designers, knowing what the regulations are and making sure that you're designing a system that not only cleans up the environment, but is good for the homeowner and at a reasonable cost. There's always a need for that. Right now, I'm sitting at the ADQ office, and right next door are a bunch of the experts in the state and even across the nation. Many are vendors, distributors, and manufacturers. They're always looking for good help to send out their product and get their products installed and making sure that the products are installed correctly. On the practical side, inspectors and pumpers. If you're looking for job security, everybody will always continue to use the restroom, and inspectors and pumpers will always be a necessity. And like I said earlier, tune in Friday, but scientists and engineers, right? Arizona is facing a water crisis, and being able to figure out how to reuse this water effectively and multiple times before it even goes out into the disposal field. If you have the mental capacity and want to pursue that, again, U of A, there's plenty of other schools. We're always looking for scientists and engineers to come up with the next big design for the on-site system. All right. Here's my shameless plug for the rest of the week. If you own an on-site system, tune in tomorrow. Doug will be talking about the care and feeding of your system. This protects your investment, right? This protects your health. This protects the environment. Don't be afraid to tune in and find out what I mean by the term feeding. Thursday's presentation is going to be done by Kathy. If you are running an in-home business on an on-site system, tune in, find out what some of the do's and don'ts are, figure out how to best make use of your system without destroying your system. And then again, on Friday, tune in for the future of Arizona's on-site systems. All right. I might have ran through that a little bit quick, but thank you guys. And if you have any questions, let's start fielding some of those.
Well, thank you very much, Alex. You know, it's I don't know, it's kind of a simple system, but there's a lot of different parts to it. I mean, the idea is but so to get through it in 15 minutes, I think that was great. And we've got a good turnout here of attendees. We've had some questions put into our Q&A, and so I'll start those. And I guess this is the time to ask the hard questions. We got Alex with us here. And the first hard question is, what's the deal with flushable wipes?
So,
are they really flushable?
Flushable means it can be flushed down a toilet. That does not mean it should be flushed down a toilet.
Or a good idea.
All right. I guess this will be my little spiel on advertising is designed to make you guys want to do whatever they tell you to. That does not necessarily make it the right thing to do. So when they advertise that it's a flushable wipe, you should still not be flushing that down the toilet. You should still be throwing that away like you would any other refuse.
It's not going to break down that fast, and it's not going to break down inside your toilet tank, is it? I mean, septic tank, is it?
Correct.
Yeah. Okay. So that's simple enough. Next question. Is 5 to 6 feet depth of leach pipe a problem?
So I guess the follow-up question would be, is your leach pipe installed at 5 to 6 feet down, or do you have 5 to 6 feet of depth below your leach pipe before you hit one of those limiting conditions I talked about? To break that down,
Perhaps they'll need to clarify that question, but I'm going to assume that there's a leach pipe and it's at least 5 to 6 feet deep.
Right. So I'll adjust both of those actually.
Okay.
So back in the day, a lot of systems were under what, right, daddy knows best. They did what they thought was best at the time. And there are a lot of existing systems where the leach pipe is really deep in the ground. Now, I mentioned that the microbes are what's breaking down the effluent. And again, microbes require air, and you're not going to get a whole lot of air 5 to 6 feet down. Will it still work? Yes. Will it work effectively? Not as well. Now, if you have 5 to 6 feet of good soil between the bottom of your leach pipe and your limiting layer, then that's going to affect the size of your field. Right now, Arizona code requires 4 foot of separation between the bottom of your disposal works and a limiting layer, and 5 foot of separation between the bottom of your disposal works and the water table. So if you only have 5 to 6 feet, talk to your designer and figure out how to best design that field to make use of what soil you do have.
So how close should that leach field or leach pipe be to the surface to maximize kind of the oxygen to, being safely underground?
Okay. So under Arizona code, your minimum depth is 15 inches from the bottom of your leach pipe to the top of your 2 grade. That includes either a 3 or 4 inch perforated pipe.
Okay. All right, next question. Are chlorine tablets in toilet tanks a problem?
So everything needs to be done in moderation. If you think about a microbe, it's a living organism just like us. So if something is harmful to us, it's also harmful to it. Now, there are, right, especially with COVID, there are certain microbes and viruses that we don't want. So we need to get rid of those. But we still need to, again, in moderation, account for the good microbes that are acting in our system as well. So I would recommend that you don't use chlorine unless you have to.
Additional chlorine in your system is just going to be tough on the bugs because it's going to do its job. It's going to change the pH. It's going to kill them.
Right.
Okay. How about this? Can I garden above the leach field?
Yes, you can plant stuff above the leach field. Now, a couple things to be aware of when you do that is roots always go for the water. So if you plant trees, odds are you're going to get roots in your leach field and it's going to back up your system pretty quickly. If you want to plant some sort of crop that you want to harvest and eventually eat, remember that what's coming out of your system is effluent. It's human waste. So you probably don't want to actually be harvesting vegetables and fruits above your leach field. Now, certain alternative systems are designed to have effluent that's been cleaned to the point of, as I mentioned earlier, reuse, in which case those are great for watering.
So, yeah, you know,
So
you've got effluent there.
Right. It depends. Ask
yeah.
Ask the guy who did your design.
So all matter of a distance there, because I don't know if maybe a raised garden would be safer, but then again, then you're building something on top of that leach field, so just respect that space. Okay. How about, is evaporation above the leach field normal?
Yes.
Yeah, it should be evaporating. That's going to be all part of that, just exchange of air and water and so on. Okay. How often should the system be pumped out?
That's an excellent question. So that depends on the use of the system, the size of the tank, and the number of people. So I don't have it with me, but Gila County has a lovely owner's manual that actually has a chart that tells you you should be pumping this much if you have this many people. If it's a rental, odds are it's going to be, the system itself is going to see more use, so that needs to be pumped more often. If you have 7 people living in a 2-bedroom home, then that system was designed for a lot less people, so that's going to need to be pumped a lot more often. I will get an electronic copy of that homeowner's manual to Chris so he can post that, and then you can take a look at that chart and see how often you should be pumping your system based on your situation.
Good. I've seen that chart. I do have copies of that book in my office that I've gotten from Jake. And, you know, like you said, it just depends on how many people are in the house. So, you know, if it's a small family, it can be every 3 or 4 years. If it's a lot more people using it, yeah, it just depends. So it does matter. Okay, so the next question is, I was hoping to see diagrams and explanations of how alternative systems function, specifically drip filled evaporative. Is that on Friday?
I can't speak for that. Unfortunately, I don't have any diagrams on alternative systems. I will talk with Joel and Azara, and if we can get a list together, we'll get you some diagrams to
perhaps we relay that question to Joel and see if we can get this covered, because that was, I think, the day we're going to talk about it. Okay. Good question. Good question. Maybe I'll just copy it here to make sure we deal with it when we should. Sorry about that. I'm trying to just want to make sure I got that. Okay, moving along, guys. Next question. if an old system doesn't have an inspection port at the end, is there anything I should do to find it or put one in, etc.? How do I end an endpoint, do an endpoint inspection? Just dig around and look, or not be concerned about it? So an old system, no inspection port.
An old system was put in, again, with the understanding that it was, at that time, that was how it was done. If you would like to get an inspection port put in, I recommend, there are numerous contractors throughout the state who are all registered with the ROC who do wastewater. They can find your system, they can find the end of your lines, and they can install the inspection ports themselves.
Get a professional. Good in. Okay. All right. Next question. Is it practical to add a leach field inspection port to a 1990s septic system? I think you just said yes.
Yeah.
Okay. How can we increase the good bugs? And is vinegar bad?
So the good bugs actually come from our body. Believe it or not, when we use the restroom and our stool and our urine, all of that has microbes that are actively contributing to the system. So just by continuing to use your system without putting in chemicals and things that kill bugs, you'll eventually increase your good bugs. Vinegar is not as, just like anything, right? There's a moderation to be used. So don't be pouring gallons of vinegar down your system, but a little vinegar is not a problem.
It's probably, we've got surfaces that we're cleaning, and whether it's bleach or vinegar, whether it's alkaline or acid, it's just going to be, it will probably take quite a bit before it starts to have an impact on the septic tank, but we don't know what quite a bit is. But normal cleaning shouldn't be an issue. Would that be about right?
Yes. Now, I would say normal pre-COVID cleaning. Ever since COVID, people have really started upping the use of bleach and alcohols. Again, washing your hands every now and then, right? Using soaps. Again, don't go overboard. Don't be pouring tons of chemicals down your system.
Along that line, what about those antibacterial soaps?
Right.
Probably not a good thing.
Right. In the name, it's antibacterial, and we're counting on the microbes, which are bacteria, to treat the system. So by using those, you're killing the good along with the bad. And I won't go into too much detail because that's going to be a good chunk of what Doug will be discussing tomorrow with the care and feeding of the system.
Good. That'll be tomorrow's discussion. Okay, so what leaching system is the best?
So this depends on the situation. You're not going to put a leach field in an area where you only have 12 inches to a limiting condition, but you also don't want to spend an absorbent amount of money if you can get a standard system on that property. So it all depends on the site conditions. With that, I mentioned soil and percolation testers. They're the people that do the site evaluations and let the owner know what's exactly going on their site. And then the designers are going to be basing their design on those numbers, those facts. So again, it kind of depends.
Lots of factors. So not an easy answer after all. But specific, but there's one, but that'll be best for their specific situation. So
right.
Talk with a professional.
Talk with the designer. Yep.
Yeah. Okay. Next question. I'm having my home power washed within feet of the leach field with a 3-to-1 bleach solution. Will this be an issue to microbes?
So fluid always moves in the downward direction, right? The old plumber's adage is everything flows downhill and paydays on Friday. So if that all of that liquid is getting into your leach field, it's affecting both your biomats and the microbes that are eating that biomat. Again, just like any other, using bleach or any other chemicals, it affects the system to the degree. It depends on the situation that it's in. I would recommend making sure that when you're using this solution to power wash your house, that you try and berm and keep the flow away from your system.
So you can berm it, you could probably cover it with a tarp and make the water go somewhere else, and other things to just direct it so it stays out of the leach field, because that is pretty, that's a lot of bleach, I think, 3-to-1 solution. Anyway, okay. This I like this question here. Next one says, is the very green grass above each lead fill pipe good or bad?
All right, so it's referred to as lush green, and that is an indication that something is not functioning properly in your field. Usually that means the effluent is not going down and away like it should, but instead rising towards the surface. So talk to a wastewater inspector and see if they can figure out if there's possibly something wrong with the disposal works, such as roots in the pipe, or if maybe something is affecting the way for the soil to, for the water to disperse through the soil.
So probably not a good thing to have green grass above the leach field there. Yeah. Okay. Next question. You got lots of questions. You're doing great, Alex. You're popular. You just leave lots of time for a question and they'll just ask them. And please do. We got plenty of time still. All right. So next question. Since you are recording this webinar, will we be able to access it later to watch again? Yes. Yes. So I'm recording this. It will go to University of Arizona YouTube channel to begin with. So we convert it to YouTube, and then we'll make that available to Azaura so that, we have another place that we can make these available. And that should all be happening hopefully by the end of the month, but it'll take a few days for people on campus to make the conversions and make them available and us to share that out. Okay. Next question. Are there any bad clothes washing detergents?
Again, it's a matter of moderation. Usually when you wash whites, you do a little bit of bleach. Again, a little bit being the key word there. Same with detergent. Don't use an exorbitant amount. And if you're finding that your system is not functioning properly, cut back on the use of those detergents, those chemicals, the bleach. And again, the body will naturally produce enough of that good bacteria again to keep the system, to get the system back into its proper state.
And that's going to be covered tomorrow as well. So tune in tomorrow. We're going to have Doug with us, and I think he's going to be able to answer some more of these questions about what not to put into your tank. Okay, next question. Oh, another one of these. Impact of commercial toilet bowl cleansers. I think we had that discussion already. Go ahead.
So again, tune in tomorrow. Doug will be discussing quite a bit of, again, the do's and don'ts, especially when it comes to what to be putting down your system and what not to. Commercial, I would not recommend using anything that says commercial on a residential property.
Okay, good. Okay, next, can you post the link to where the recordings live? Thanks. I've been sending, and yeah, I'll put that link in here where they'll live. Yeah, okay. And kind of okay, here's another one of those questions. Does Rid-X do any good?
So going back to what I was talking about with the advertising on flushable wipes, Rid-X does an excellent job of advertising that you will not have to pump your tank as often. but it fails to recognize that the system, it contains two parts, the tank and then the disposal field. What Riddix is doing is it's taking those insoluble scum and sludge and making them soluble so they go through in that clear zone and then end up plugging up your disposal field in the, which of the two parts of the on-site system, replacing a failing tank is a far easier thing to do than replacing a failed leach field.
Yeah, like you say, it's largely marketing. And the last question about the post for the links, I just put that into the chat box. So Sonny, you can grab that and make it and save it. Lisa just clarifies one part bleach to 3 parts water and TSP for that power wash. Okay. And I think Jake added powdered detergents have non-degradable fillers. So any of those non-degradable materials in the detergent can clog up your leach fields. We want to steer clear of those. Lots of good questions. That right now we're kind of at a standstill for questions. We've had a good turnout here today, Alex. We were up to about 25. And so I'll give it a few more minutes. Anybody wants to add anything else, they can put a question in here or in the chat. If we leave a little bit early, I'm sure nobody's complaining.
Okay.
And yeah, go ahead.
No, I just
okay. We've got Alex's information here. Feel free to call that number. I'm pretty sure it's the Gila County Health Emergency Management, the engineering department there. So you can get through to Alex, probably get through to Jake. If you've got any problems in Gila County with your septic tank, this is the place to call. And I imagine if you're participating in this, it'll give you kind of a special end too, and they'll do their best to answer your questions. So let's see, maybe a few more questions popped up since we, yep, we made that request. So people saying thank you. So we go in a little more depth here. Recently acquired a home. I noticed a small sunken 4-foot circular area near where septic pipe enters the leach field. This is now a second home, used very little, and it's not worsening. Any current concerns?
So if it's a pipe straight to this area, based on the description, I'm going to assume that's a cesspool. So again, upgrading that is beneficial to the value of the property. However, and there's plenty of financial backing that you can get. There's grants and low interest loans and all sorts of things done through the federal, state, and sometimes even the local levels. So research into that. If the system itself is not backing up, if it's not failing other than this, well, depending on the sunken home, I'd say maybe contact, again, installer or inspector and have them take a look, see what's actually going on. If they can do a non-invasive look and figure out if it's actually just maybe the ground caved in and there's a sinkhole there, or maybe it is the start of a failing cesspool. Either way, you would want to know about that so you have the best information to decide what to do moving forward.
Should probably look into that, right? Yeah. Okay, Sonny's asking, is there a phone call in? Sonny, send me an email address. I'm going to go ahead and put an email message. I'm going to put that into the chat box, but it's also with the announcement that came out in the email. And I can go and find the, Zoom invitation for the webinar where to have the phone in information. Okay. Next question, is it acceptable to put copper sulfate in the sewer line to keep roots out of the line from the house to the septic system?
Okay, that will most likely be something that Doug will actually discuss again tomorrow, as far as how to prevent root invasion in the system. I'm gonna go out on a limb here and say you don't want roots to invade your system. So a little bit of preemptive maintenance is good, but again, don't go overboard. And Doug can correct me if I'm wrong tomorrow.
Okay. Have somebody thanking us, very informative. And got the phone call in for taken care of. I think our person has somebody living at that property, so they're having some trouble with getting the inspection there, but who knows? I'm not too sure how that all works. What is the best way to have your septic system pumped?
So there's countless pumping companies throughout the state of Arizona. So contact your local county representative. They should have a list of people who are active in their county who pump systems, and ask for that list, and then give them a call and figure out what their lead times are and what their prices are.
Yep, just work with, that's what they do. Okay, so this person will look into that system status, but it was a 1976 home. Are there any regulations for outhouses?
So yes, what a cesspool is an outhouse that's tied to the house. And so outhouses are considered, just like any other cesspool, a direct into the ground system.
So,
so the use of them is prohibited under Arizona rule.
the use is prohibited. Yeah. And so though we've exhausted, no, here comes another question. Where do they dispose of the debris after they pump the septic tank? So where do they take all that sludge and septic material?
So that all depends. There are numerous wastewater treatment facilities across the state who handle septage, which is what it's called when it's pumped out of the tank. And so the pumpers know where the nearest facility is that accepts that, and that's where they take it. Sometimes they have to drive quite a ways to get to that facility.
But basically anybody who it's their job to be pumping tanks, whether it's the plumber or whatever they are, they're, regulated by the state. The state knows who they are, and they're obligated to follow all those rules. Yeah. Okay. I got Jake raised his hand. Should I take the risk of allowing Jake to talk here? Think I'll, because well, let me go ahead and do it. Jake, we'll put you on here. You can unmute and add something to the conversation here. Or did you accidentally do that?
I raised my hand by mistake, and I would, as Alex knows, I always have something I want to say. And so it's been very fun for me to sit here and not be able to talk and listen to the great job Alex is doing. And I'm going to leave it at that. So this was a mistake, and I appreciate everybody being here, and well, let's just leave it at that. Keep tuning
Very
in.
good.
And as Alex has said many times, tomorrow Doug will be doing a great job of addressing the care and feeding of your septic system. And there were a significant number of questions today in that arena. And Doug has spent years digging into systems and correcting them and fixing them and doing all, making them work. And so please tune in for Doug on those questions.
Great.
And I'll hang up here.
Okay. Well, Alex, I guess we'll shut it down here. Thank you so much for your time today and information, your expertise. We had Lots of questions, good turnout from our people attending live. So thank you, everybody. As Jake Garrett just shared, please tune in tomorrow at noon. We have Doug Disbrow, who owns Arizona Wastewater Services, LLC, and he'll be talking about the care and feeding of a septic tank. And so ways that you can be a good septic owner, and what not to put into your tank. So we can get into some more good discussion on that. And with that, everybody have a good rest of your day, and we'll see you again tomorrow.
Thank you,
Bye-bye.
Chris.
You're welcome.